Hello and welcome to the Year 8 topic Chemical Interactions. This is taught by Mrs. Castanera here, and we'll be going through this topic. Now this is a different front cover to the one you will have had or seen previously, but don't worry, it just needs to say Chemical Interactions on your front cover and it will be the same content inside. So you will have a knowledge organiser similar to this. There are 27 statements that you will need to learn. Okay, make sure you know those all of those by the end of the topic. There's also a periodic table on the third page of the booklet. I strongly recommend keeping this separately and keeping it handy, as you will need it throughout the entire booklet. Okay, so we're going to start with lesson 1, which is covalent bonding. So there is a knowledge check here. So what I'd like you to do is, I'm just going to give you a quick edit to this question 7, and then you're going to pause the video afterwards. So question 7 is incorrectly worded. State the number of energy levels period 3 elements have, is what it should say. So how many energy levels do elements in period 3 have? That is the correct question for question 7. So pause the video, have a go at those questions, and we'll go through them in a few minutes. So we're just going to go through those. The two main sections of the periodic table are the metals and non-metals. Metals are on the left, non-metals on the right. The group with unreactive elements is the noble gases, also known as group 0 or group 8. Either of those is an acceptable answer. These noble gases are unreactive because they have a full outer shell. They neither need nor want to lose any electrons because their shell is full. The reason atoms want to fill their outer shells is to become stable. Once an outer shell is full, then the atom is stable. The alternative name for shells is energy levels. Okay, so a shell is an energy level. How many valence electrons do group 7 elements have? So valence electrons means number of electrons in the outer shell. Group VII, that's Roman numerals for 7. So they have 7 electrons in their outer shells. 7 valence electrons. The number of electrons in the outer shell is the same as the group number. State the number of energy levels period 3 elements have. Well, they're in period 3. Each period represents an energy level. So they have 3 energy levels. And name the 2 subatomic particles found in the nucleus. They are protons and neutrons. Now give yourself a mark out of 8 for this. So tick it if you got it right, and correct it if you got it wrong, and give yourself a mark out of 8. So as I said earlier, this is lesson 1, covalent bonding. The keywords for this lesson are listed here at the top. They are atom, element, reactive, shell, valence electrons, bond, and share. You will need to know what these words mean in both scientific and regular vocabulary to be able to fully access this lesson. By the end of this lesson, you should understand what all of these words mean. So today we are going to describe how non-metal atoms form covalent bonds. So how do non-metals bond? Okay, so we know that metals form positive ions and that non-metals form negative ions. This then causes the oppositely charged ions to be attracted to each other due to the electrostatic forces and form an ionic bond. So metals and non-metals are oppositely charged. They're therefore attracted to each other, and that's because of the electrostatic forces between positive and negative that allows them to form an ionic bond. We already know this. This is ionic bonding between a metal and a non-metal. However, what if there are no metal ions to bond with and only non-metals are available? all of the non-metals form negative ions, and we know that only oppositely charged ions attract. So how do non-metals bond together if they all have the same charge? So we know that non-metals all form negative ions. So if you have a group of negative ions, then you are not going to be able to get those to bond together using ionic bonding, because negatively charged ions will repel each other. Okay, so we have a different type of bonding. We're going to write a note about this. Okay, so we'll write a couple of notes, in fact. Firstly, we are going to write that like charges, so similar charges, repel. Okay, up at the top here, we're going to write that ionic bonding is a metal ion, in fact, and a non-metal ion. Okay, and they are chemically bonded together through the process of ionic bonding. Now, next to here, we're going to write covalent bonding. And that happens when you have two non-metals. Okay, so covalent bonding is always between two non-metals. So activity 1 here is about valence electrons of these non-metal elements, and you're going to need your periodic table to help you. So we're going to identify how many valence electrons there are for each of these elements. So, as we said, chlorine has 7 valence electrons, and it needs 8, so it needs 1 extra electron to complete its shell. If you're happy with what you're doing now, if you want to pause the video and go ahead and complete the rest of the questions, and then once you're done, unpause the video and we'll mark them together. If you're really not sure here, we will have another go, we'll do another element, and then you can have a go at the rest of it on your own. So continue watching for another example if you're not sure what to do. So the next example we're going to do is we're going to do oxygen at the bottom here, okay, because fluorine is very similar to chlorine, that's the F. So O. So we look for our O symbol on our periodic table, and it is just here, and O is in group 6. So group 6, that means it has 6 valence electrons, that's 6 electrons in its outer shell. And what we can do is we can write in here that that is 6 electrons in the outer shell, and it needs a total of 8, so it needs 2 more electrons to completely fill that outer shell. So if you are happy with what you're doing now, I want you to go ahead, pause the video, and then we'll review the answers when we're done. Okay, so here are the answers to that exercise. We're going to mark them. So fluorine had 7 valence electrons and it needed 1 more, as we said. Carbon had 4 valence electrons, needs 4 more. Nitrogen had 5, needs 3 more. Oxygen, as we did as our second example, has 6 valence electrons, needs 2 more. Hydrogen has 1 valence electron, and if you remember what I said earlier, it only needs 1 more because it has a maximum of 2 electrons in that first smaller shell. Helium has 2 valence electrons, although 0 is also an acceptable answer, and it does not need any more electrons again because it's in that smaller first shell. Silicon has 4 valence electrons, and so it needs 4 more to make 8. Phosphorus, that's the P symbol, has 5 valence electrons and needs 3 more. Argon, Ar, that has 8 valence electrons, though 0 is an acceptable alternative answer, and it again does not need any more electrons to fill its outer shell. So if you could give yourself a mark out of 18 for that, please. And then we're going to move on. So before we start the next section, I'd like you to watch a video about covalent bonding. So you need to open up your browser and get Google search up, and you need to type in cognito covalent bonding. So that's cognito, C-O-G-N-I-T-O, covalent bonding. So you want to click on the first term that comes up. And it'll bring up this video, and the title of the video is at the bottom. It should say GCSE Chemistry -Covalent Bonding number 14. And this is part of a series of videos done by Cognito. They're all very good if you want to watch any of them at any time. But today we're just going to be watching this one on covalent bonding. So if you pause the video now, you'll be able to watch the video and then come back and we'll continue with the lesson. So now that you've watched the video, we're going to come back to some more about covalent bonding. So forming covalent bonds. So nonmetals are short of valence electrons. So they will try and gain electrons to fill up their outer shells and become stable. So if you're writing notes rather than having a copy of this, you'll need to write this entire sentence, please. It's very, very important. Other nonmetals are in the same situation. None of them want to lose electrons, so they decide to share them instead. And they do that by forming a covalent bond. Each nonmetal will share one of its electrons with another nonmetal. They share a pair of electrons, which means the outer shells have to overlap and therefore they become bonded together. A covalent bond is a shared pair of electrons. That's really important. That's a definition for what a covalent bond is. So a covalent bond is a shared pair of electrons. Covalent bonds are very strong. Hydrogen atoms have one covalent bond between them to form a hydrogen molecule. The bond can also be drawn as H with a dash and then another H, and that single line, that dash, represents the pair of electrons that they are sharing. So, for example, up here in this diagram, we have two hydrogen elements. So this hydrogen, which I'll highlight in orange, has this electron. And this second hydrogen, which I'm going to highlight in pink, has this electron. And so what happens is our hydrogen atoms share their electrons in this zone between them, this overlap. I'm going to write a couple of notes here. So the two atoms share a pair of electrons between them. That is exactly what covalent bonding is, the sharing of the electrons, and this bonds them together. Okay. Now, so here we're forming, this here is a hydrogen molecule. Now, just a reminder, definition of a molecule is two or more atoms chemically bonded together. So molecule is two or more atoms chemically bonded together. Okay. So this alternative representation of H-H, and I'm going to write that again at the top here, H-H. This is a really common way of representing a really common way of representing covalent bonding. So that single line is representing the pair of electrons. I'm going to highlight that, that's important to know. You'll be asked to do this later on in this lesson. So for example, if we cover over one of these hydrogens, it still looks like the other hydrogen has a full shell, and we can do the same on this side, cover this hydrogen, and the other one still looks like it's got a full shell. And so both of them appear to have their two electrons. They don't actually gain an electron, but they do become stable because they appear to have filled their outer shells, that is their highest energy levels. So they don't actually gain an electron, that's very important to know, but they do become stable because they appear to have filled their outer shells or their highest energy levels. So now we're going to look at drawing the atoms of non-metals. Okay, so activity 2. So these are electronic structure diagrams. Electronic structure. So we're going to do the diagrams of the electronic structures. So again, we're going to need our periodic tables for this. So first of all, we're going to look at chlorine. And we looked at chlorine at least once already this lesson. So here it is again, and it's in group 7. So our group 7 element is going to have 7 electrons in its outer shell. Okay, that means it needs one more to fill the outer shell, which we've already done. We already know that from our previous exercise. Now you're going to need a pencil for this. So if you get yourself a pencil, if you don't have one, pause the video until you can get yourself one. So using our pencil, we're going to draw in the first full shell, which has got 2 electrons. Then we're going to fill in the second shell, which has 8 electrons, because it's only the outer shell that is sometimes not full. So for chlorine, our outer shell's got 7 electrons. I'm going to start at the top. 1, 2, 3, 4, 5, 6, 7. Now, this style of drawing these electrons that I've done, doing them in little pairs together, this is the accepted format that scientists use when drawing these electronic structure diagrams. Now, electrons are negatively charged particles, so they repel each other. However, we don't really teach this until you're a lot older, but electrons like to go around in pairs. Okay, there's a reason for that. It's quite complicated. We're not going to worry about why, but the electrons like to go together in pairs, and each pair of electrons will repel the other electrons far away from it. So we spread them out in pairs as far away as they can get from each other, except for this little lone electron all on its own. We call it a lone electron because it's just a single electron left behind. Okay, so what I want you to do now is complete this task for the following 3 elements, and in fact, it carries on onto the next page for 4 more elements. Okay, now if you're confident with that and you're happy to do that, I'd like to pause the video now and work through those. If not, I'm going to go through the next one. Well, I'm going to go through oxygen with you, and then you can pause it afterwards. So for those of you that would like a second example, we're going to do oxygen as our second example. Now, oxygen is in group 6. Okay, that means it has 6 electrons in its outer shell, 6 valence electrons. So here we will write 6 because it has 6 valence electrons. That means that to get a full shell of 8, it will need 2 additional electrons because 6 plus 2 is 8. Now, remembering that it has 6 electrons in its outer shell, we're going to fill in the inner shell with 2, and then with the outer shell, we're going to go round until we get to 6. So 1, 2, 3, 4, 5, 6. And so we've got 2 over here that are not paired off. Now, you don't have to draw it exactly like this. You are well within your rights to draw it like this, or in fact any arrangement really, as long as you've got 2 single electrons and 2 sets of pairs on the outer shell. Okay, so now that you've had a second example, please go ahead and do as many as you can of the remaining ones. Okay, so we're just going to go through the rest of these now. You should have a pen ready to mark in a different colour to what you've used so you can do your corrections. Now, fluorine in the periodic table is above chlorine, another group 7 element. So we're going to write it's got 7 electrons in its outer shell, and it will also need 1 electron to complete that to 8. Again, it has 2 electrons on its inner shell, and its outer shell arrangement will be very similar to chlorine with just the 1 lone electron there. If you got those right, give it a tick. The answer to oxygen is here. If you got it right, give it a tick. Make sure you're ticking your diagrams as well. And helium, very simple helium. It has 2 electrons in its outer shell, as shown by its position here in the periodic table in group 0. So it's got a complete shell. So it has 2 valence electrons and it requires no more. So tick, tick, tick. Now I'm going to show you the ones that I've already done on the next page. Okay, so on the next page we have nitrogen with its valence number of 5, so it's got 5 electrons, so we've got a pair here on the outside and 3 singles, and it needs 3 more to complete its shell. Argon has a full outer shell, so it's got 8, or 0 is an alternative acceptable answer, and does not need any more to fill its shell, so that should have a full set of 8 electrons in the outer shell. Neon is in the same situation, it just has 1 less shell. And again, it's got all 8 electrons in its outer shell. Again, 8 is a good answer, 0 is also an acceptable answer, and it does not need any more electrons to fill its outer shell. Then we have carbon, which is in group 4. Okay, so it has 4 electrons in its outer shell, so it doesn't have any pairs of electrons here. And it will need 4 additional electrons to fill its outer shell. What I'd like you to do is give yourself a mark. So each tick is worth a mark, so there are 12 on this page. And there are 9 more on this page, okay, which I'll give you another one for this one because you had to do that, so that's 10 plus 12, so give yourself a mark out of 22. Anything above 15 is excellent. If you got less than 8, then I think you need to have another go at this task. So we're going to move on to drawing covalent bonds. So the diagrams you've just done should be very helpful for you, or at least the corrections if you've had to do that, that's also fine. A really good tip here is, as a starting point, draw the largest element first, the one with the most shells. Okay, so we're going to do ammonia. So here's ammonia, and I've pre-filled this in for you. So here we have nitrogen, so it's got 2 electrons in its inner shell, and it's got 2, 3, 4, 5 electrons in its outer shell, so just 1 pair and 3 lone electrons. Now with the hydrogen, because I've done this in pencil, I've used a circle to represent my electron on my hydrogens here. And the way that fits together is I have my my pair of electrons here, and I have each of my single electrons attached to one of the single electrons from the hydrogens, and they're sharing those pairs. And this is NH3, which is ammonia. So your task now is on activity 3, and what I need you to do is just draw the outer shell. You don't need to draw all those smaller shells that are full inside, just draw the valence electrons this time, the outer electrons. I'm going to work through an example with you, and there'll be a second example if you need it, and then I will share you the answers. So there are 8 of these to complete, and they get progressively harder. So the first one we're going to do together is hydrogen. So for this task, you can either draw circles freehand using your pencil, or if you have one, you can use a compass and protractor and do it that way. So to do this, you simply draw your 2 circles. And it's very important that your 2 circles overlap. So for this one, this example will be hydrogen. I'm going to mark one of the hydrogens with the H in red, and the other hydrogen in green. And as you can see, they're sharing their electrons there. We can do the same thing for every other element here. So chlorine, it's very similar. There's even a hint. So there are 7 valence electrons, but only 1 pair of electrons are shared. So it's going to look similar to this, but they're going to have the remaining 6 electrons around the outside. So if you're comfortable and you think you can do this, I'd like you to pause the video now and carry on working through it. If you're not sure, then I'm going to do HCl Hydrochloric Acid to demonstrate the next one. So first of all, for this, you're going to want to draw yourself 2 circles. One to represent chlorine, and a smaller one to represent hydrogen. They don't have to be different sizes. I've just done that because I know that hydrogen is a much smaller element than chlorine, but it doesn't matter if yours are completely different sizes or the same. So again, I'm going to draw one of the hydrogens in red, okay, and show it with a red cross. You can use dots, crosses, it doesn't really matter. Typically we use crosses, but when there's more than one element and we're showing that they come from different elements or different atoms, it's absolutely fine to use a mixture of symbols like crosses and circles. So this one is chlorine. Now chlorine has 7 valence electrons. So chlorine has 7 valence electrons, and we know that because it's in group 7. So starting from the top, 1, 2, 3, 4, 5, 6, 7. So here we have our example for hydrogen chloride or hydrochloric acid, and that's how we do that. So I'd like to pause the video now and continue working through that. If you're marking, just carry on. So here we have the first 4 answers. Make sure you tick each one to check it's correct. So I've already been through hydrogen and chlorine, or hydrogen and HCl, hydrochloric acid. Just to walk you through chlorine, it's very similar to the hydrogen. They share a pair of electrons and they have 6 other electrons arranged in pairs on each atom. Fluorine is very much the same as chlorine. Exactly the same pattern. I've done it backwards to show that the colours can be any way around that you want. It doesn't matter which one's which colour. Moving on to the bottom 4. These are a bit more complex. So oxygen has only got 6 electrons in the outer shell, 6 valence electrons. So I've put my X's here and here. Now, positioning isn't terribly important, okay? If you haven't positioned yours like mine, that is absolutely fine, don't worry about it. What is important, however, and will affect whether it's right or wrong, is whether or not you've managed to get all 4 of your crosses in this little zone of overlap. Even if, like my one, it's only just in the zone, that's absolutely fine. And this is what we call a double bond, where 2 sets of electrons are shared. So you can see there are 2 red electrons from this oxygen and 2 green electrons from this oxygen. Here we have hydrogen. So each hydrogen is sharing its black electron, because it's already been printed in black, it's a black X, with a red electron from the oxygen. And again, I've put those electrons so that they are spaced evenly apart from the other pairs of electrons, but again, it doesn't matter too much where you've put them. Here we have carbon dioxide. We're getting into the really tricky ones now. So carbon only had 4 electrons, so it's going to have 2 double bonds, just like oxygen, but 2 of them, one on either side. And the oxygens are going to do the same approach as before, with their remaining electrons spread out. And the carbon, the CH4, carbon here, this is methane, is going to have 1 electron shared with each of the 4 hydrogen atoms. So what I'd like to do now is give yourself a mark out of 8, please. So don't worry too much if you've managed to get one of the last 4 wrong. Okay, I'm much more concerned about you getting the first 4 right. So if you've struggled with the first 4, then you need to rewind and listen to this video or the internet video again. However, if you've only made mistakes that are small errors, particularly on the bottom 4, don't worry too much, okay? You will get better at this with more practice and over time, and we do lots more of this in our GCSE courses. So we've come to the final part of the lesson, the knowledge and application check, where you figure out how much of the lesson you have understood and how many of the questions you can answer. There are 11 questions for you to do, so you need to pause the video, and when you're done, unpause it and we'll go through the answers. Okay, so let's go through those answers for the knowledge and application check. The charge of non-metals, when they turn to ions, always have a negative charge. And that's because they gain electrons. Now, question 2. The electrons found on the highest energy level are the valence electrons. Non-metals will try and gain electrons to fill their outer shell. 2 non-metals will share some of their valence electrons. A covalent bond is a shared pair of electrons. A covalent bond only forms between 2 non-metals. If 4 electrons are shared, we say there is a double covalent bond. Covalent bonds are very strong. Okay, so on to the trickier questions. So this is the covalent bond formed in hydrogen fluoride, HF. So we have our hydrogen here with 1 electron in its outer shell, and we have our fluorine atom here with 7 electrons in its outer shell, and they are sharing 1 pair of electrons here. So if you got that right, tick it. If not, feel free to draw it here or on the student notes page or on the back of any of these pages. Question 10. So this was the diagrams from learning activity 3, which we just did. Okay, so this time we needed to replace the bond here with the line to represent it. So H-H, H-Cl, O-O, because that was a double pair of electrons. There were 4 electrons there, 2 pairs were shared. O-C-O, Cl to Cl, F to F, H-O-H, and then the C in the centre with 4 hydrogens surrounding it, each with a dash between the H and the C. And why do noble gases, although they are non-metals, why don't they form covalent bonds? And that's because they already have full outer shells, so they have no need of covalent bonding. So I'd like you to give yourself a mark out of 18 here, making each of these worth 1 mark. So anything less than 6, and you really need to review the contents of this lesson again. If you've got more than 12, excellent work, you've done really well. That's wonderful work. And we've come to the end of our lesson now. If you have any questions, feel free to email your teacher. You should have their email address, and if not, the addresses for all your teachers are on the school website. Thank you very much.